Hello, and welcome to the IMTS Spark virtual conference and the quality inspection track entitled the Non-Contact Metrology Software Toolbox. Performing critical measurements with non-contact sensors requires sophisticated software. You'll learn how advanced software technology is used to get optimal performance from video, laser, and other non-contact measurement devices. Our speakers today are Colby Finn, Vice President, Strategic Marketing at Optical Gauging Products, hereafter referred to as OGP, which is a division of Quality Vision International. And she'll be joined by Jim Stern, Applications Engineer Manager at OGP. Colby Finn has a Master of Business Administration and a Bachelor of Science degree in Optical Engineering and has been working for OGP in the non-contact metrology industry for 14 years. She's had many roles, including working in applications engineering and product development. Currently, she leads the strategic marketing group for OGP. Jim Stern leads the application engineering group for OGP. He's been with the company since 2010, starting as an applications engineer. He's also been involved with the product software management and development with OGP. Jim has a bachelor's degree in mechanical engineering from Rochester Institute of Technology and worked in fixture design prior to working for OGP. I'm this session's moderator, Eric Brothers, Senior Editor of GIE Media's Manufacturing Group, which includes the publications, websites, social media, and digital offerings of aerospace manufacturing and design, today's medical developments, today's motor vehicles, and today's e-mobility. Each title focuses on design and manufacturing topics specific to its industry to give our readers insights to improve productivity, lower costs, and be successful. I'll be collecting your questions for Colby and James to answer at the conclusion of their presentation. Attendees, please scroll over the bottom of your Zoom window to show the Q&A feature that you can use to ask your questions. Colby and Jim, the forum is yours.
All right, thanks, Eric. We'll get started. So today we're going to talk about software tools for the optical measurement of manufactured parts. Whether it's video measurement, laser measurement, or 3D scanning, Jim and I are going to share tips and techniques for you to better choose the best technology to measure dimensions on your parts. So if you're not familiar with our company, we're from Optical Gauging Products, or OGP. We've been in the dimensional metrology business for a little over 75 years. So what's unique about our company is we design and manufacture just about everything that has to do with optical measurements. Transports, measurement sensors, optics, and software. So our most well-known product is the SmartScope 3D multi-sensor system. You can see one on the screen over here on the left. And a SmartScope really combines all of our technologies and innovations into one product. So we are an international company, but we are headquartered in Rochester, New York. And what's great about that is Rochester is the #1 region worldwide for optics and photonics research. So there's a lot of top universities and other companies investing in optical technology development. So in addition to our New York office, we have other offices in the United States, as well as Europe and Asia. So like I mentioned, we have been in the business of optical metrology for a little over 75 years. And we've been part of a major transformation in this industry. When we first started, all measurements were taken with the human eye, like you can see on the screen, with an optical comparator. But ever since we introduced the first grayscale subpixel image processing for a video system in 1980, software became a key component of video measurement. And now today, it's hard to find any modern piece of measurement equipment that doesn't require software to take a measurement. So why did this transformation occur? The obvious answer is software is more efficient than humans. You gotta pay people, they get tired, they complain, they make mistakes. But people are actually really good at some things related to optical measurement, such as automatically recognizing parts, detecting dirt, whether it's from your part or not from your part. And it's taken many, many years to get image processing software to the level where it can mimic human ability in video measurement, but also not require a lot of training. So today we're going to talk about how software technology continues to push optical metrology forward, both related to capability and ease of use. So we organized our software tips based on the reasons people choose non-contact measurement technologies, say over traditional technologies like tactile CMM. And there's 3 reasons. The first is they're faster. You can get many measurement points and many dimensions in one shot with optical technologies. Second, they're better, meaning for some applications, you get more accuracy and higher resolution. This is specifically true for small parts with small features or delicate parts that you don't really want to touch. And lastly, they're easy to use. So when you're programming a measurement system, teaching it what you want to measure, when it's an optical system, you see a live image of your part. So it makes it very easy to interact and get immediate feedback on what you're measuring. So today we're going to talk about software tips for video measurement and 3D scanning separately. So both technologies have the same goal to measure dimensions on your part, but there's different strategies and best practices for each. Video measurement, you're usually measuring feature by feature or getting coordinates, where with 3D scanning, you're measuring and grabbing data on your entire part at once. So Jim is going to show you software tips for video measurement using OGP's Zone 3 metrology software package. Zone 3 is the software that acquires and analyzes data from OGP's 3D multi-sensor systems. And I'm going to show you 3D scanning tips using Cotem's Evolve suite. So Cotem is a sister company of OGP. We're both divisions of QVI. And the Evolve suite is a model-based suite of software packages. The main goal of Evolve is to make an organization get more value out of GD&T. It has different software packages for different parts of the manufacturing enterprise, meaning design engineering, quality control, and manufacturing. And we're going to focus on the quality control package today called Evolve Smart Profile. So Smart Profile takes in measurement points from any device and fits them to a CAD model to evaluate the GD&T. So we're going to get started with video measurement, and I'm going to hand it over to Jim. Before he gets started, he's going to give a quick demonstration of the machine he's going to use to show us software tips. So if we can make Jim's video large, and I'll get out of stop sharing my screen for a second.
So, hi everybody, thank you Colby for the introduction. Thought we'd start off with just a little preview of the system. A lot of my slides will be showing, so really the star of the show is the Fusion 400 that I have here. Now this is a 3D large field of view system. It has both optical paths for a large field of view and a higher magnification path for 3D measurements, being able to do Z measurements with optics, focus, all right? It also has a multitude of sensors that you can apply to this system, all right? An interferometric through the lens laser, as well as scanning probes that are all concentric to the optics to increase your measurement range on the platform, all right? So what's unique about this system, it is a large field of view system, but also a 3D multi-sensor system, bringing both versions of a large field of view platform and a higher magnification optical system into one to be able to increase throughput, but also be able to measure prismatic parts as well. All right. So now we're going to get into a little bit about some of the unique things you can do with optics. All right. So first, we're going to start off with one of the big reasons you use optics is faster measurements, or using video to measure features faster, all right? The key to measuring as fast as possible with video is to use the largest field of view that has enough accuracy and resolution for your part and your individual features that you are measuring, all right? So now we're going to show a little video example between what you might have and what you can do with a larger field of view system. So what you're going to see here in the video is a traditional zoom system, all right, with a smaller field of view, all right? So we're going to be measuring a multitude of diameters on this part, all right? So this traditional field of view system has a smaller field of view to start, but also has a optical zoom system to be able to increase accuracy and your optical magnification on the features that you want to measure, all right? So maybe this is not the system or the field of view that you might want to use for this system when you're doing repetitive dimensional checks like these diameters going around this parts, because it takes up to 5 minutes. Now, let's do the same part on the fusion system here, where you're going to see a large field of view and be able to see all the measurements at once. Now, while using software, we're able to measure all these diameters in a single field of view all at once, now reducing our inspection time to 10 seconds, all right? Another benefit of large field of view is that it allows you to recognize and align parts automatically. This is possible in Zone 3 at any field of view and on other systems like the traditional one we showed. But it is more efficient when you have a large field of view to see the entire part that fits inside that. So right here, we have parts set down on the stage, no specific orientation or fixturing, and then we're going to search in a specific area to be able to automatically recognize the part and then inspect all the dimensions that we need to in seconds, showing you a visual representation of what part passed and what part failed, so an operator can easily grab off the stage which ones they might need to reject or which ones they're going to keep. All right. Now, with having large field of view systems, one thing you got to be aware of is some of the caveats that can go with that. If you're going to take advantage of these entire field of view systems that they have to offer, you need a very high quality lens design combined with advanced software compensations to get the accurate measurements that you're looking for. We're not going to go deep into the optical lens design theory, but there are two things that are extremely important for video measurement, especially with large field of view systems. Getting the same results anywhere in the field of view, which equates to your distortion across that field of view, and getting the same results even when you aren't at the perfect focus of the system, which represents your telecentricity. Here is a visual example of a system with poor optical performance for video measurement. As you can see, near one side of the field of view, you see the right wall of a straight down bore. Near the other, you see the side of the left wall of the bore. This is evidence of major optical errors. Now, this is a gross example, but the tricky thing is an image can look perfectly fine to the human eye, but have huge errors across the field of view and the depth of focus or the range the image looks in focus. We aren't talking microns, but hundreds of microns. Published accuracy specifications don't typically apply across the whole zoom range. So you can't just assume your field of view is good by what you see on a technical data sheet. At OGP, we've learned you need to have lens designed specifically for your video measurement and software that understands the characteristics of your exact lens to get an accurate optical performance. Our large field of view systems go through rigorous alignments, compensations, and testing in the factory to ensure they will meet your customer and your specific subpixel accuracy expectations. And what you get is the images that you see on screen now, all right? Our recommendation is to go with an experienced video measurement system vendor you can trust or get educated on tests you need to perform to confirm your video system is optically accurate. I would also recommend a real-world test of your application on the system you're probably thinking of choosing to measure your parts or your applications in the real-world environment. Now, with this, you also get to use your full field of view when you're compensating for the distortion correctly with the software or any errors that might be involved. Because you have a large field of view, you want to be able to use the whole optics or what you see on screen. So as you move around the stage, you want the same results inside the accuracy specification for that field of view. So now let's get into maybe some easy video measurements, all right? So one thing you can utilize to make video measurements easier is CAD models, all right? Everybody has CAD models these days, but CAD models really simplify measuring with video. there is a misconception that programming from 3D CAD with video is difficult. Since your CAD model is 3D, hold on, let me turn the light back on. Gotta save energy. Since your CAD model is 3D and you're only seeing a 2D video image on screen. But this is definitely not the case, and I will show you a couple examples of this. All right. So what you're seeing here is a 3D CAD model loaded into our Zone 3 software. All right. It comes in CAD coordinates, but it's not really where it is sitting on the stage. So what we can use is the large field of view to automatically figure out where the part is on the stage using our reposition via video option in Zone 3. Now, once it figures it out, it places on the stage in the real world where it is, all right? So now I can quickly start measuring features on that CAD model using automatic path generation using our edge detection feature finder. Once that's done, I can then use the CAD model to automatically search for similar features and automatically program the extra 5 circles that you see. We can optimize that to then utilize the field of view to automatically measure that in one single spot on the field of view, trusting that we get the same results because we're compensating for any kind of errors across that whole field of view. Another misconception is being able to measure features that might not be able to be measured using backlight, all right? As well as complex curves or geometries that you'll see here. I'll select multiple curves into one finder, all right, and then use the system to automatically generate a path to measure these features with our feature finder tool all at once, all right? And then we'll go automatically to where it is and then measure this automatically with our feature finder tool, all right, breaking up into lines and arcs based on that complex curve. All right. Those were some tips on how to get faster and better easier measurements with video sensors demonstrated by the OGP Zone 3 software. But now I'm going to send it back over to Colby to give some tips for 3D scanning using Evolve Smart Profile. All right, there you go, Colby. Thank you.
Great. Thanks, Jim. So like Jim said, I'm going to show faster, better, and easier tips for 3D scanning. Before I get started, I'm going to show you the machine I'm going to use for my demos. So let me stop the share for a second. Get started. So this is a OGP Shape Grabber AI 320. What Shape Grabber systems are automated laser scanners for fast 3D measurement. The system can take more than 1 million points a second. So the laser line scan head moves up and down behind this cover here, and your part automatically rotates on the rotary here for full 360 degree coverage. So this system here can have up to a 190 by 300 millimeter cylindrical measuring range. And this is our most compact automated unit. But we do have larger systems that can scan parts longer than a meter. So this system also has a tilt axis that actually tilts the scan head. It's motorized, it's automatic. And that way you can scan the top of your part without having to pick it up, flip it over, rescan it, and use software to stitch it together. So what's unique about our Shape Grabber systems is they provide high accuracy over a large measuring range, and they're automated. All the operator has to do is push a button, the machine starts collecting data and produces results. So we'll go give some software tips now. So we'll go back to the presentation. Second. So our first tip is for faster measurement. Now I'm going to show you how to do fast GD&T with a 3D scanner. So there's a common misconception that you cannot do 3D GD&T with a 3D scanner. That's because with GD&T, every point matters. If a single point is outside your tolerance zone, your part fails. So there's 2 reasons people don't like to use 3D scanners for GD&T. The first is the data's too messy, meaning there's noise writing on the points or there's outliers, and therefore every point isn't valid and you can't do reliable GD&T. The second reason given is there's just too much data. So the processing to do GD&T properly with all the optimization just takes too long. So I'm going to show you a new software technology that allows you to overcome these issues and do fast GD&T with 3D scanner data. So we're going to use Evolve Smart Profile and a CAD model to do very quick GD&T. Sorry. So the first step here is to import your CAD model and tolerances. And if your design engineer didn't embed the tolerances in the model, you can readily add them in Smart Profile. Once you have everything in there, you're going to import your measured points. I'm going to use points from my shape grabber system here, but Smart Profile can take points from any device, whether it's a CMM, laser scanner, CT scanner. So you'll see my points in a second. It's the green scan cloud. And I took 5 or 10 million points with my scan, and the parts scan pretty well. You don't see a lot of gross outliers, but it's still not ready for GD&T. There's still a little bit of noise running on the data. So we have to prepare our point cloud for GD&T. And what Smart Profile has is an algorithm that was designed to take 3D scanner data and make it ready for GD&T. It's called the CMM-like sampler. I'm going to run that now. So we call it the CMM-like sampler because the resultant point cloud we're going to get is going to look like a high density point cloud taken with a CMM. And similar to CMM data, all the points are going to be valid in X, Y, and Z, and therefore you're ready to do GD&T. So I don't know if you can see it through the video, the tiny little, the green points on the model are my points after the CMM-like sampler. So now we're ready for our fourth and final step, and that's to evaluate the GD&T results. So the software is going to fit the point cloud to the CAD model, run a bunch of optimizations to simulate hard gauging and give you GD&T results. So you will see here that everything passes. And what I was showing you was a step-by-step of how to process 3D GD&T with Smart Profile. But all of the steps from data acquisition to reporting can be fully automated. So you don't need someone here clicking the buttons. You can get it a fully automated workflow. So this demo was how to get fast GD&T with a 3D scanner. And now we're going to move on to how to get better data from a 3D scanner. So more accurate results from 3D scanning. So I'm going to show you a software technique that allows you to get better measurement results without investing more money in hardware. So we're going to show a new software compensation method called Boost. And what Boost does is lets you take the accuracy of a reference machine and map it onto the data from either a cheaper or less expensive or a faster technology that's not quite as accurate as the reference device. So I'm going to show you an example of Boost for 3D scanning. And Boost is part and method specific, which means you have to create this compensation for every part and machine combination you want to give this accuracy boost to. But luckily, the software does most of the work for you, and I will show you the 5 easy steps to both create the compensation and measure your parts in production. So the first thing we're going to do here is select a master part from our production run and measure it on both our high accuracy device, in this case, a CMM, and our fast production technology, in this case, our 3D scanner. Once we have the point clouds from both devices, we're going to load them into Smart Profile, and it's going to automatically create that dynamic compensation. Again, this is going to map the accuracy of the reference device onto the data of your high-speed device. So you'll see on the screen, the little whiskers represent the point-based compensation the software is doing. So once you have this map created, you're done with your reference CMM, and you're ready to measure production parts. So step 3 here, we're actually measuring our parts with our very fast technology. And now step 4 is to apply that boost compensation. So we're going to, in Smart Profile, we're going to click the boost button, and it's going to make those production points more accurate. So now that we've done that, the last and final step is to evaluate the GD&T of the compensated points that are more accurate. And now everything passes. So similar to our last demo, all of these steps can be automated, and I'm going to show you a quick video of what that looks like and what our typical production workflow is like. So here is your typical automated workflow. The operator pushes scan and the machine starts acquiring data. As soon as it's done, the points are going to automatically go into Smart Profile, and Smart Profile is going to automatically start evaluating them and produce a report. So this was a way to get better data using software for 3D scanning. Again, so you can use software, so you don't have to invest as much money in hardware. So our final tip for 3D scanning is about making measurement easier. We're going to show you how to do easy 3D GD&T failure correction. So GD&T can save a company a lot of money. But that's only if the entire manufacturing operation is applying it correctly, meaning the design engineers entered the correct tolerances, the quality engineers evaluated them appropriately, and the manufacturing engineers know how to adjust their processes to get parts to pass. And we're going to focus on that last aspect, the connection between quality and manufacturing. So say your GD&T fails. What do you do to get future parts to pass? Machinists are used to working in their machining coordinate systems with their fixtures and their control points. They don't want to adjust their process based on our profile tolerances and our GD&T datum structures. So I'm going to show you an easy software tool that takes GD&T results and translates them into machining corrections to get future parts to pass. So this is a new simulation and optimization tool that's part of Evolve in the product Evolve Manufacturing. So we're actually going to start out where we left off with the other two demos, where step 1 is to evaluate our measurement points for GD&T. But this time I'm going to have a bunch of failures. You're going to see a lot of the red on the screen. Red is bad, means things are failing. We're going to focus on this total runout tolerance of a cylinder relative to datum C right here. So if I click on that, I will see the points and see how it's constrained to the datum. And say I wasn't quite sure exactly what this call out meant, I could click on our explanatory system, and it's going to bring up the exact part of the GD&T standard where that call out came from. You can see the diagrams and everything. But even if I'm educated on total runout, I still don't know how to fix this failure. Was my cylinder manufactured wrong, or was my data machine in the wrong position? So that's the problem our software is going to solve for us. In order to do that, the software needs to know the manufacturing details. So we're either going to import from CAM or enter the manufacturing coordinate systems and tell the software how the features are grouped together by machining operation, meaning which features were machined together. With this information, the software can run what-if simulations. What if I shift operation 1 over a little bit? Would that make my GD&T results pass? So now that we know which features are machined together, we're going to go into our simulation wizard here. And in this wizard, I'm going to tell the software what manufacturing operations I want to allow to be adjusted. And I'm going to select operation 1, which made that, that datum C that could be problematic. Then I'm going to check optimize and have the software run the simulation. So what it's going to do is calculate the best adjustment to that manufacturing operation, to get the GD&T to pass. So when this is done, you'll see a recommended adjustment, and then you'll see the simulated results of what the GD&T would look like if manufacturing made that adjustment. So first, we'll look at the recommended adjustment, and the software, I'll show it in a second. It calculated that we should shift operation 1, that datum C, over an X and Y by about 0.1 millimeters. And the simulation results are shown in the model window with the little arrow showing before and after. If we were to apply that manufacturing adjustments, the results after the arrow are simulated results, and that total run out tolerance would pass. And if you look, actually everything's passing now. So that datum C was my whole manufacturing problem. So with this information, the quality engineer is now armed to go talk to manufacturing and know how to fix parts going forward so future parts pass. So that demo showed how it's easy to communicate between quality and manufacturing with the Evolve suite. The whole goal of Evolve is to help a company implement GD&T across the entire enterprise. So that's our final tip. And the key takeaway from our presentation today was that advanced software makes optical measurement faster, better, and easier. Therefore, you should take the time to learn and implement new software technologies to help you better measure dimensions on your part. And that's it. So I'll turn it back over to Eric and see if there's any questions. On my screen share.
Thank you, Colby and Jim, for explaining non-contact metrology with some new software technology. We have some time for questions. I have a couple here to start. First of all, what color light is used on your scanning? Is that white light, or is there a particular wavelength?
This is a 405 nanometer wavelength laser, so it's like a blue. So the shorter the wavelength, the higher resolution you can get. So that's why we picked the shortest wavelength for our scan head.
Okay, is that across all of your platforms, or just is that for the laser?
It's for our laser on this latest shape grabber platform.
Okay.
We also have different wavelength technologies on our smart scopes for different applications.
Okay. So I had a question. How much part rotation is necessary for accurate scanning, such as deep holes? Some of those parts carry very complex shapes. So is there any guidance on that?
Well, with optics, you have to be able to see it to measure it. So it all depends on the geometry of your part. If you have something very complex, yes, you may actually have to pick it up and rotate it to get in there, even with our multi-axis systems that we have here that are super flexible. So.
Okay. Is there any way to palletize parts for loading to go through and automate that process if you have to validate every single piece?
Oh, for sure. All of our systems at OGP are equipped for automated measurement, pallet loading, robotic feeding, that kind of stuff.
Okay. Here's a question. What formats can that point cloud be sent out to from the shape grabber, such as file formats STL, STEP, IGS?
Pretty much anything you want, to be honest. You can do IGS, you can do STL, you can just get a simple man-readable XYZ. All the popular standard formats we support.
Okay.
If there's any specific one, please feel free to reach out to me.
All right. Another question. Do you support the ASME Y14.5M-1994 standard for geometric dimensioning and tolerancing?
So yes.
Or a GT&T. That's a mouthful.
So we support all of the GD&T standards. The Y14594, like you just mentioned, 2009 and 2018. Also the ISO 1101. And also the Japanese geometric general tolerancing standard JETA. That's for like block tolerancing for geometries. We support them all. You can readily switch between them, so it's not like you just pick one and you're stuck with it. So.
Okay. What CAD formats does your software support?
Jim, you want to handle it?
Yeah. From the Zone 3 side, standard, we support STEP, IGES, DXF, Gerber, Epsilon. Then we have options for native CAD support for Unigraphics, Creo, and Pro-E, CATIA, SolidWorks, or Inventor as well.
Okay. Jim, while you're there, can Zone 3 auto recognize a part larger than the field of view?
Yes, it can. Actually, during that video, I had a part, and they weren't all in the same field of view. So what it does is, if it notices a part is touching the boundary of the optics, it will then start edge tracing or searching around the part to then get the total form of the part to then recognize it. So yes, we can auto recognize a part that is larger than the field of view as well. So that's why even with Zone 3 on a smaller field of view system, you can still utilize auto ID. It's just the large field of view sometimes is more attuned to using auto ID in Zone 3.
Okay. Here's a question about the shape grabber. How does the shape grabber handle highly reflective parts or black plastic? Do they have to be sprayed with a matte surface?
So if you look, so this part, this is the part I use for the demo. It's actually pretty reflective and it scans just fine. So laser is actually less sensitive to shiny reflective parts than say like structured light. But there are some cases for like mirrored surfaces or that kind of thing where you could spray developer. And black plastic parts are no problem at all. We have plenty of intensity that you can adjust on the system and scan black plastic just fine.
Yeah, and another thing to know is with a shinier part, you may just need to do more slices to be able to get more points on it, because again, shiny material, it'll shoot it off, and it's more about the collection of the light back to the sensor. So you might just need to do more slices to be able to get it if it is extremely reflective, but you can still get data points on it without having to code it.
All right. Here's a question for me, I guess. It says, will there be a recording that we can watch later? Yes, there will be, and you'll be notified by email on how to access that. Any other questions? All right. Well, thank you for that very informative presentation. And thank you for your questions, audience. And thank you, Colby Finn and Jim Stern, for your knowledgeable presentation. Don't miss these upcoming IMTS Spark conferences. Today at 2 p.m. Eastern, Making the Digital Transformation Leap. This presentation with Marcus Stolmar, President and CEO at United Grinding, will focus on the basic building blocks of the digital transformation, the development of technological digital product architecture of a multi-brand and multi-CNC machine tool group, and how to drive cultural change to use synergies in digital project development toward a united Industry 4.0 solution. On Tuesday, January 12th at 12:30 Eastern Time, don't miss the conference, How to Leverage the Digital Twin to Optimize Datum Features and Validate Geometric Dimensioning and Tolerancing in order to reduce manufacturing costs and lower risk of defects, presented by Maria Harangas, Senior Dimensional Engineer and FEA Specialist at Dimensional Control Systems, and Paul Vickers, Senior Dimensional Engineer Specialist at DCS. On January 12th at 2 p.m. Eastern, the conference is The Business Case for Autonomous Mobile Robots in Manufacturing, with speakers Matthew Chang, Chief of Strategy and Innovation at Pulse Integration, and Matthew Rendell, CEO and co-founder at ClearPath Robotics and Otto Motors. Watch your email for invitations to register, or you can find more IMTS conference sessions at imts.com/spark. Thank you and goodbye for now.
Thanks, everybody.
Thank you, everybody.
Thank
Bye.
you.